the worksheet, okay? Because I'd rather have you ask questions about that. Some of you did not have a real solid background with factoring, and that's nothing against you. That's just where your school was with their algebra curriculum. So understand, we just want to update it and make sure that you do this in order for you to be a little bit more confident next year going into college algebra or going into Algebra 2. So, first thing you need to understand, the steps in factoring, and I'm going to give you the shortcut steps, all right? What's the first thing you should always do when you're factoring? What should we look for? Always look for a greatest common factor. An example of this would be something in this manner. 3x squared minus 9. What would be my greatest common factor in this? 3. And you get 3 times the quantity what? Minus 3. That is the best. It's completely factored. I can't factor the next one further, the x squared minus 3, because 3 is not a perfect square number. And remember, if you're factoring, notice I didn't say solving. Do you see an equal sign anywhere? Equal signs mean you give me an exact answer. Factoring means you just break it into its parts. So there's a difference. Now, if there was an equal sign here, then you'd set them both equal to it and go from there. But that's not what's here. Here's another one for you to try. What if I had something like this? 3xy squared plus 5x squared y. I'm going to ask you to factor this. Heidi, what would you take out? Yeah, just an x and a y. I kind of like it when you have variables you can take out. Because literally, if you look at the exponents, you can only take out the smallest one. So for the x's, I can take an x out of both one. So here, you should get 3y plus 5x. And that's the most you can factor that one. Yeah, there is 2 variables. Okay, you can do 2 variables. You got the gift. You can do it. But that's always look for the greatest common factor. Why? Because if the numbers can be smaller, life is easier. And remember, when you're writing your final answer, that greatest common factor is part of the answer when you're factoring. So that's the first thing you should always look for when I ask you to factor. Here's the second thing you should always look for because it makes your life a lot easier. Always look for a difference of 2 squares. Now, I didn't do a lot with this. You don't need this, but it sure saves a lot of time. Let me give you an example of this. That's a multiple step problem. Here's my problem. I get 2x squared minus 8. What's the first thing I need to do? Greatest common factor, which is what? 2. Then what's left is an x squared minus 4. Now, here is the difference of 2 squares, right there. To get an x squared minus 4, here's the way that you know it works. First of all, it has to be a subtraction sign. That's where the difference comes in. And both of these have to be perfect square numbers or no-go, okay? It doesn't work. That's why x squared minus 3 didn't work earlier. But if you get that, you can factor that into 2 binomials. You just take the square root of each one. What's the square root of x squared? X. Square root of 4? 2. And this is what's really cool. This is where the conjugate binomial thing comes in with factoring. And what we were doing earlier, plus, minus. Because if you do this, when you do your FOILing, to go backwards to check your work, guess what the O and the I do again? They cancel out. Which leaves you an x squared minus 4. Yes, ma'am?
If you have, like, if it was just x minus 4, then
you're done.
it wouldn't work,
Right, it wouldn't work. It has to be a difference of 2 squares. Yes, ma'am?
what was it positive?
Wouldn't work. You couldn't factor it. You just have to leave it that way. It has to be that subtractor sign or it won't work. And that's where you just, it's one of those things you have to memorize. If I got an x squared plus 4, no go. So you have to make sure it works that way. So this is the one that's completely factored. Here, though, be very careful. I've seen stuff like this happen before. I have x to the 4th minus 16. And I want you to factor it. Is that a difference of two squares? Is 16 a perfect square number? Is x to the 4th a perfect square number? All right, so I go, all right, two sets of parentheses. I can do this. Square root of 16, I got 4 and 4. I have a plus and a minus here. What's the square root of x to the 4th? Are we done with factoring? Because what just happened? I got another difference of two squares. So I have to go one more time. So this x squared plus 4 comes along, but this new difference of two squares has to split up. And that's when I get my x plus 2 and I get my x minus 2. Now that happens fairly regularly in algebra 2 and college algebra. So be careful. When you're factoring, you always have to keep checking. Can I factor more? Yes, sir. You can keep them separate or together, doesn't matter. Like here, I didn't put a big one here because once I factored out, if I multiply them together, it would get the same thing. But you could keep it there and it'd be no big deal. What you're just telling the people if they look at your problem is just multiply these together first and make your life easier, basically is what you'd be telling them. Does that make sense? Do you guys remember doing difference of two squares? And I'll tell you, you don't have to focus on these a lot if you know the rules.